KPM. Didik TV KPM.
Hi, Mr. Q.
Hi, hello Tivia.
Oh my God, that's a very tasty nasi lemak there.
Yes, so this nasi lemak, have you eaten one of this before?
Of course, nasi lemak is one of my favorite Malaysian dishes. But speaking about nasi lemak, right? Why do we have nasi lemak today?
Okay, first of all, I would like to introduce some of the materials that are inside this nasi lemak dish.
Okay.
So we have the egg,
Yes.
we have the groundnut, and we have cucumbers and also anchovies, not forgetting the rice.
Okay, yes.
So-
it smells very delicious as well.
So this nasi lemak has got to do a lot about the topic that we are going to learn about today, which is
Okay.
about mixture.
Mixtures. Right, okay. That's pretty much why we have nasi lemak today. Right, let's find out more about it.
Shall we start eating first?
Alright, let's eat. Should I open my one?
Yeah, sure, of course.
Okay. Good day everyone, how's everyone doing? Hope you're having an amazing day. Today we are joined here at Didik TV KPM for DLP Science Year 2. Together with me, Tivia, and our studio guest, our lovely teacher joining us is none other than Mr. Quek Chok Q, Mr. Q. Hello Mr. Q.
Hi, Tivia.
How are you?
I'm good.
Right, all ready to begin our session, am I right?
Yes, all ready.
Right. Without further ado, let me also quickly introduce our lovely interpreter joining us is teacher Kulina, all the way from SMK Sultan Abdul Samad. So without further ado, I'm sure we looked at the delicious nasi lemak earlier with what is inside, the mixtures and all, right? And today, right now, we have changed into like an experiment table. I'm sure Mr. Q is going to surprise us with something. So please tell us, Mr. Q, what do we have?
Today, we are going to learn about the topic mixture.
Okay.
Okay, and then the first, in this segment, we are going to talk about how do we separate materials? How do we separate the mixtures into materials that we want?
Okay.
Okay, so in front of us there are altogether 5 types of experiments that we are going to do here today. Okay, so the first method is about handpicking.
Handpicking.
Yes. So
Alright.
in front of us we have this
Dates.
mixture, right? So we have the red dates and the goji berry. So
Okay.
this is the goji berry, and this is the red dates.
Yep.
So by using our hands, so
So
I'm
are you
going-
going to do the first experiment right now?
Yes, we are going to do it right now. So
Okay.
Tivia, could you help me to
Yes.
separate it? You take the
So-
red dates, I'll take the goji berry.
Okay, so we're going to be doing it together. So
Okay.
people at home, this is the first experiment that we're doing, and we are separating in terms of,
Yeah.
handpicking.
Yes.
That's the first experiment
The
that
reason,
we're doing.
the reason why we are using this method, the handpicking method, because both goji berries and the red dates are large in size and they have different shapes. So we can easily identify them. That's the reason.
Basically, because it's larger in size and easier for us to identify the shape, right?
if it is
of
in-
both the berries and the dates, so it's easier for us to handpick.
So if one of it is in a powder form, it's going to be tough for us.
Yep, okay. So now that we have separated and it looks,
Yeah.
I'm going to show it. Yeah, right? There's
Yep.
the hand picking
Method.
method. Yeah.
Okay, so I hope everyone at home, you can use this method when separating larger objects.
Yes.
All right?
Okay.
So the next method that we are going to look into is the
Second
sieving method.
Sieving method.
So as you can see, this is a sieve. Okay, this is a sieve, and in front of us here, I've actually mixed. I have a mixture here. Okay, this mixture is actually a combination of raisins and also flour. Okay. So
I'm sure this is the method that I often see moms use at home. Am I right?
Yes, of course.
Right. Okay.
So because these materials, one of them is in powdery form, powdery solid form, and another one it's a larger size. Okay, so we cannot use the method that we used just now, which was the handpicking method.
Okay.
So now we're going to try use this sieving method.
Okay.
Yes. So I'll have this in front of it.
Okay, Mr. Q is
Would
going to do
you-
the honor.
Yes, I'm going to hold this.
Okay.
Can you pour it?
Okay.
Okay.
So slowly, huh?
Yeah, sure.
Okay.
Okay, so
A bit
as
scared, I don't know,
as
to
Stevia
pour.
is pouring it, okay, you'll see that the powder or the flour, the powders, it
Should I pour everything?
Yes, pour everything.
Okay.
So, okay. So then after
Alright.
Tivia pour it, I'm gonna sieve it now. Move it around. So what is left?
Okay,
is
that's
going to-
beautifully sieving, right?
Yes. And then finally we were left with the raisins.
Wow, like a magic.
Yes. Okay. So this is how we sieve, especially we can only use this method for solid objects.
All right, powder, and when it's mixed with solid,
Yeah.
we use sieving for easier separation.
Yes, because later on we will see another method which is similar, but that one is got to do with the liquid and the solid.
Okay.
So this is only for both solids.
Can I see?
Yes. So now you have the raisins. The raisins actually covered in flour.
Yeah. Okay.
Okay.
So this is pretty much how the raisin that's also covered with flour, and now it is beautifully separated. I feel very bad for separating everything, but that's the lesson that we are learning today, people at home, in terms of separating two different, items,
Materials, yeah.
materials. Yes, that's right. Okay, so what do we have next, Mr. Q?
Okay, moving on. We're going to do a little fun experiment which is
Okay.
called the magnetic attraction.
Magnet.
Okay, so magnetic attraction, as you see here, I have what is it called? Paper clips here. You're going to put it inside this container full with corn kernels and also sago seeds.
Okay.
So, as you know, the magnets can only attract objects that are made by iron.
Correct.
So this method is effective to removing iron from certain, what do you call?
Certain mixture.
Yes, certain
Right.
mixture.
When there's a magnet and if there's any iron around a mixture, we put a magnet and it will attract it, right?
Yes.
Okay.
Can you
When
try
I was in school, I loved doing this experiment. So I'm sure people at home, it's going to be very fun as well. So, correct,
just
right?
want to-
Just like that.
Just move it. Okay, can put it up.
Wow. There you go.
Yes. Okay, so this is the third method that we have just introduced to everyone at home, yeah?
Can you do it one more time?
Yeah, sure.
Because it's fun, a bit fun. One more time for people at home. So you just...
You can get all this in shops, stationery shops, if you want to play with
this looks nice. I think very nice to witness science in hand.
this. Yeah.
Okay.
Okay, the following experiment is about flotation. So
Okay.
I have a mini aquarium here. So this mini aquarium, it's filled with wood debris.
Okay.
So if I want to remove this wood debris, it's going to be hard, right? Because it's all
Mixed.
mixed up together.
Okay.
So what we're going to do is, could you help me open the bottle of water?
Sure.
Okay, so Tivia, you just pour water inside this mini aquarium.
Okay.
Just keep pouring until it's almost full.
Mr. Q asked me to pour slowly, so I don't,
Okay. All right. 5 more seconds. 1, 2, 3, 4, 5. Okay. So from here, we can see that the wood debris is actually floating.
Yeah.
So this is a simple way of how to remove the wood
Wood.
debris. Yeah.
Right, okay.
So you can remove the wood debris from
The sand.
Yes.
Right, that's one way of separating.
Yes. Then you can get a clean aquarium for your fishes to
Yep.
swim inside.
All right, so
Okay.
that's flotation.
Yep.
Okay.
And finally,
The final method.
Yeah, the final method is called the filtration method.
Filtration.
Okay, so in this, do you know what's inside this, Sylvia?
Let me see. Is it tea?
Yes, it is tea. So it's one of, as a Chinese, it's one of our favorite drink.
Is it Chinese tea?
Yes, Chinese tea.
Chinese tea is also one of my favorite.
Okay. So,
Okay.
as you can see, it starts to change color, right?
Yep.
Okay. So, but the problem with drinking tea like that is we find it, what do you call?
Disturbing.
Disturbing because the tea leaves are stuck inside our
Yeah.
tongue. So what we can do is we got to filter this out.
Okay.
We're going to filter this
That's
out.
what we're gonna do.
Yes, because filtration method is basically for separating materials that are solid and liquid form.
Okay, different materials
Yes.
that are together, we try to separate it.
Yes. So, so this is a filter funnel. This is how we're going to do it, right? And then I have the filter paper. Put it on top. All right. Okay.
Okay.
And you're gonna put it here. And I'm gonna pour the
Okay.
liquid inside.
Should I hold it?
Yeah. It's okay. Sure. Okay.
So the leaves, right? The tea leaves will be filtered out.
Yes. Then you can enjoy your tea better.
Okay. Right. So people at home, while waiting for that, water to just run down,
I think I have a question.
Oh,
for
you have a question?
Yes.
Okay, tell
me. Since we have already learned 5 methods to separate mixtures.
Okay, it's a question for me
Yeah,
or
the first-
for the people at home?
I think this is for you.
For me.
Okay.
Okay.
What is the best method to separate paper clips and staples?
Paper clips and staples. So paper clip is what we saw just now, right? It's the
Yeah.
iron. And staples. Two also iron. Two
Yes.
also. Can I use magnetic for both?
Do you think you can use magnetic?
I'm not sure. Tricky questions. People at home, help me out here, okay? If there's staple, if there's paper clip, then how do we separate it?
Yes or no? Can we use magnetic attraction?
The only separation method that comes to my mind is actually magnet, because I know magnet can separate iron.
Yes.
But please tell us, what is the right answer?
Okay, the right answer is by using handpicking, because
okay.
if both objects are made of iron, it's impossible to use the magnetic attraction to remove the two
Right, okay,
materials.
both also will be attracted to the magnet.
Yes.
Okay.
So as you know, both objects are also large in size. So the best way is to use the hand-picking method.
Right, okay. With that, people at home, I'm sure you are also confused and at the same time enlightened, right, about what's happening right now. And go home, right, at your own home, go and find a stapler, find a paper clip, and see how you can attract or separate it using magnet and see if it works. If it doesn't work, then we need to use hand pick, like what Mr. Q mentioned. Right, with that, people at home, do that experiment on your own while we go for a very short commercial break, and we'll be back very shortly.
KPM.
Welcome back, people at home. Have you managed to separate the stapler and the paper clip? If you have tried with the magnet, I'm sure you know the hand picking is the best method, like what Mr. Q has taught us. Hello, Mr. Q, welcome back.
Hi, hello, Tivia.
Okay, so we did discuss a lot about a separation method together with Mr. Q and in the topic of mixture. So in this particular segment, what do we have, Mr. Q?
Okay, so in this segment, we are going to talk about soluble materials and also insoluble materials.
All right.
So basically, soluble materials are materials that can dissolve in water, whereas insoluble materials are materials that cannot dissolve in water.
All right. So today we are going to be experimenting that, correct?
Yes. So in front of us we have this corn kernel.
Okay.
So we're going to do a simple experiment where we are going to place sugar
Okay.
inside this container filled with
Together
corn
with
kernels.
corn.
Okay.
All right.
So we'll see whether the sugar or the corn kernel remains after adding water inside. Okay.
Okay. So we're
gonna
going to
add-
be seeing it's going to be dissolving or not.
Yes.
Correct? Okay. So people at home, you can see whether if we put the sugar inside, is it dissolving, together with the water.
Okay.
Right? Okay.
So now I'm going to place water inside this container.
So it's a warm water? Is it hot water?
It can be warm.
Okay.
It can be normal, room temperature water.
All right. Regardless.
Yeah, regardless.
Okay.
Okay, so what we're going to do now, we're going to stir this up.
Okay.
So we're going to stir it.
So as we stir, we could see the color changing a bit.
Yeah, okay.
And
But do you
looks
see
like-
sugars inside? Do you still see the sugars?
Looks like it has dissolved. Looks like I can't see
It's not-
any sugar, the small particles inside.
Yeah, so it's not visible anymore, correct?
Yeah. So people at home, are you seeing what I'm seeing? So if you are not seeing the sugar there anymore, that means it has dissolved. Correct,
Yes,
Mr. Q?
correct.
Okay.
Is it interesting?
Yes, pretty much.
Okay.
Okay.
So why not we do a little bit more, test it on a few more.
Yes, please, let's do
materials.
it. So the
Okay.
people also, they understand a little bit more about the soluble and non-soluble.
Yes.
Okay.
So in front of us here we have 3 containers.
Okay.
Okay. The first container contains salt.
Salt,
The second container contains green beans,
green beans,
and the third container contains rice.
rice. Okay.
Okay. So, do you want to do it?
Yes, I'd love
Okay.
to. So,
I
where
want
do I
you to
pour
add
this?
water inside 3
All
of the,
3?
Yes. Just
All
add,
right.
Yeah.
So-
add to 3/4 full.
Okay.
Just keep
So
adding.
I'm adding water to salt, right?
Yeah, adding water to salt. Just keep pouring.
Okay.
Some more.
Okay, enough? A bit more.
A bit more.
Okay.
Okay.
Okay, so I'm going to leave it.
Yes.
And I'm going to be adding water to green beans right now. So I pour.
Okay. All right. A bit more. All right.
Okay,
Okay.
so this is green bean.
And now rice.
Finally is rice. I'll always mix water and rice at home when we cook rice.
Yes. Okay. So
Okay.
now let us stir it and see
Okay.
whether it still remains or not. Okay?
Okay.
So the first one is the salt, right?
Yes.
So I'm gonna stir it.
All right, people at home, if you are, if you have salt at home, I'm sure you have, with parents' guidance, you can also try this experiment by adding salt and water to see if it's dissolving or not, all right?
Okay, the color changes already, right?
Yes, the
Do you know
color
why
changes.
the color changes?
Because it's dissolving? The
Yes.
salt is dissolving.
Yes, the salt is dissolving inside the water.
Okay?
Then you have this. So can you stir this?
Can.
The green bean? Okay.
So right now we are stirring green bean.
Is there changes in the color of the water?
It's a little bit
Still the same, right?
still the same, but not as
Yeah.
clear as before, but not so much a difference.
Yeah, so
Yeah.
we can still see the green beans
Yes,
inside the
very
container.
visible. The green beans are still very
so
visible.
we can conclude that it does not dissolve in water. Can you
correct.
try this? The last one,
Yes,
rice and water.
finally we try to stir rice.
So is the rice still there?
Yes, we could still see the rice
Although
very
the water is a
clearly.
bit murky, but the rice is
Yes.
still present
Visible,
inside. Yeah, it's still
correct.
visible. But as for salt, it's not visible anymore.
Yes, it
Okay.
seems like it's fully dissolved.
Yes, it's not visible anymore because salt dissolves in water.
Okay.
Okay, it's soluble in water. All right. So look at this. What do you call this whiteboard? Look at the whiteboard here.
Okay.
I would like you to fill in the blanks.
All right.
So for salt, do you think it's visible or not visible?
Salt, non-visible.
Yes, non-visible. So if it is non-visible, can we conclude that it dissolve or do not dissolve in water?
Dissolve.
Yes,
Right.
correct. Well done,
Okay.
Tivia. Okay, next, let us look at green beans.
Right.
So is the green beans visible?
Yes.
Yes.
So I think both the rice and the green beans are visible.
Visible,
So
yes.
I'll just put it together.
Alright, so we can conclude that they dissolve or do not dissolve in water.
Do not dissolve.
Excellent, Tivia.
Right. Okay. Alright. With that, we kind of understood what is visible and non-visible, but also that concludes what's dissolving and not dissolving. Right. With that, Mr. Q, we're going to be going for a very short break, and we'll come back to understand a little bit more about mixture on top of understanding the dissolving and non-dissolving materials as well. With that, we'll be very back shortly.
KPM.
Welcome back, peoples at home. I'm sure you are excited to know what we are about to do for this particular segment. So let's jump right into it. Hello, Mr. Q. Welcome back. So please tell us what we have for this segment. I see we have new setup of experiments.
Yes. Thank you, Tivia. So in this segment, we are going to look at how to make soluble materials dissolve quicker in water.
Ah, okay.
Okay, so in front of us here we can see three different containers, three sets of containers. So we have the red container cap, and then we have the gold, and then the silver. So we can conclude that from here we know that we're going to do three experiments.
Okay.
Do three simple investigations.
All right.
So the first one, we are going to put hot water and cold water to see how fast they dissolve in water.
Okay. So one container.
So you're going to put cold water inside.
Okay.
What do you call this?
You're going to be putting hot water. Okay. So the first red container, I am pouring the
cold water. So just don't need
should
to
I pour
stir
it
it now.
full?
Full, yeah.
Full. Okay. Okay. So should I close it?
Yes. Thank you.
Okay.
Great. Okay, so we're going to shake it a bit.
Okay.
Just give a shake.
Okay.
Okay. So
there's a difference that we are seeing in terms of hot water and cold water.
okay, so as you can see, both of them still has sugar inside, correct?
Okay.
But which amount is more? On the left or on my right?
The hot water is left hand side. The hot water has smaller, particles
Lesser.
of sugar. Yes, lesser.
Yes, it's lesser compared to the cold water. So we can conclude that in the hot water, this sugar will dissolve faster compared to inside the cold water.
Okay.
Okay,
All
so
right.
this is in hot water, yeah?
Okay,
good.
perfect.
Perfect. Okay, the next experiment that we are going to do is we are going to put both cold water inside.
Both also cold water?
Yes. So this experiment we are going to alter. We're going to stir one of it. We're going to stir it, and the other one we're not going to stir it.
Understood.
To see which one will dissolve faster.
Okay, so I've poured mine.
Okay, then I'm going to pour mine.
Okay.
So I'm going to stir mine. Okay.
Okay.
Yours, you just.
So we're just going to leave.
Yes.
Okay.
So I'm going to stir it a bit.
So as you stir, we'll know whether it is dissolving or not. Am I right?
Actually it helps the process of dissolving. dissolving. Okay.
So mine, it's since we didn't stir anything.
Yeah, you
so
can see a
it's-
lot of sugar particles there.
The sugar is there,
Yeah.
right?
But for this, it is much lesser, right? Nat?
Yeah,
Okay.
kat sini. This one.
So
over
can
here.
you see? For this, you still can see some what you call sugar particles. But for mine, you can't see it anymore.
Yeah.
Okay, it's very little.
Yes.
Okay.
So it has dissolved when you stir more.
Yes.
Yeah,
So
dissolved
it's
more.
quicker. So if you stir a soluble material in water, it will fasten the process, make it
Okay.
quicker.
All right. So
Okay.
our silver cap.
Yes, silver cap experiment is about large, what do you call? Cube. We're using larger cubes, sugar, and the finer sugar cubes.
Okay.
Sugar, like the usual. Okay. So in this is the rock sugar. So we're going to add water inside.
Both cold water.
Yeah, both cold water.
Okay.
Okay, yours. For this experiment, we do not need to shake it. Okay.
Okay.
All right. So you can cover it up.
Okay.
Okay. Let us show towards the camera. Is this dissolving faster than this?
The
Which one
solid.
dissolve faster?
Definitely the solid is taking some time to dissolve. Seems like this finer sugar is dissolving faster.
Yes, of course, definitely, because if the material is bigger in size, it has a larger surface area. Therefore, it is hard for it. It takes longer time to dissolve.
Okay.
Compared to the ones which are finer.
All right. Okay.
Okay. All right.
All right. So what's next after understanding these three experiments?
Yes. So we are going to answer. You are going to help us answer some of the questions I have here today.
Me. So I have another question, people at home.
Yes. So let us look at the slide. Okay. So the first question is: materials can dissolve more quickly in hot water or cold water?
Materials can dissolve more quickly in hot water or cold water. I think it's hot water. From what we experimented, it seemed to dissolve faster.
Yes.
Okay.
So the answer will be the materials can dissolve more quickly in hot water than cold water.
Yes. All right.
Excellent.
Excellent.
Next question. Materials can dissolve more quickly in water if it is stirred or not stirred.
Stirred, of course it's stirred. I witnessed myself. It is, if it's stirred, it is definitely easier to dissolve.
Yes.
Okay.
Last question is: a big or small size material dissolve more quickly than a big or small size material? Which one is the answer? Which one dissolve more quickly? Small or bigger?
Small size materials definitely dissolve more quickly than the big size material.
Yes. Okay. Seems like you have get a hang on it. Good job, Tivia.
All right. People at home, we are pretty much, done. We've come to the end of our experiment and session for today. So, Mr. Q, can we have a quick summary, please, from what we have learned today?
Okay. So today we have learned about the methods, the ways to separate mixtures, first of all. And secondly, we have learned about what are soluble materials and what are non-soluble materials in water. And finally, in this segment, we have also learned how to make soluble materials in water dissolve more quicker. All right?
But overall, how did I do, Mr. Q? You need to tell how was my performance answering his questions, right?
Yes,
Please
I
tell.
think you did pretty well. I'll give you 5 stars for it.
5 stars. That means people at home also get 5 stars because they were
Yes.
helping me in that sense. All right. So pretty much, if people at home and if they want to go ahead and have a look at the subject material, where can they find it?
They can find it from the Delima KPM website.
All right. So people at home, if you could do revision, understand this experiment a little bit better, I'm sure you can head to that website and do your own revision. With that, we'd like to thank Mr. Q for being very encouraging, very adventurous when it comes to our experiments. Right. Thank you so much, Mr. Q, for joining us. And we also like to thank our interpreter, Ms. Koo, for joining us as well. And thank you so much, people at home. We'll be back in another episode. Thank you so much. This is Stevia and you're watching DLP KPM. Bye-bye.
So come to this.